This is the college placement test, and it's yellow. I see it right there in your book.
I got my answers in here.
Okay. And then I think that'll go pretty quickly. So if you knew a formula for the percentage of increase, you could calculate 21 fairly quickly. So I'm going to write out the formula for you. It is the difference over the original times 100. So the difference between 150 to 200 is 50 over the original of 150. Does that make sense so far? It went up $50. It was 150 when it started. All right. If you reduce that, that becomes 1/3. You with me so far? Times 100 will be 100 over 3, which divides out to give 33 and 1/3%.
I did that.
Well, that's okay.
But I didn't know how to explain my work from what I did.
Yeah. Well, this is a straightforward formula, and it works for percent of decrease also. It's always the difference over your original. Turn that into a decimal or a fraction and multiply by 100. And so because that's a very straightforward process, when I realized I got 1/3 times 100 wasn't come out a whole number, then I realized that it wasn't going to be the whole number ones. So this formula, difference over original times 100, is a really great, easy way of finding percent of increase or decrease, because it's just a difference divided by the original. Everybody's getting here. Yay. We're going over college placement test first because we thought that might make this afternoon go faster. Plus, anybody could have watched the video to get it if they're not here. So, in question number 22, before I even plug it in, what do you notice about question number 22? No, but I do need to do something. There you go. I can cancel those out. And now it's just 5 plus 3 square root of x plus 4. Now, if I put -4 in that, that makes that 0. That radical part goes away. You see that? And so that's why you want to reduce this first, because there's nowhere to plug that -4 over here on this 5. It's just plug it in over here. And once you realize that plugging -4 in right here makes this whole term drop off, the answer is 5. So if you see a problem needs simplifying, simplify it before you plug a number in. It might make the math go quicker. And for you, Destiny, on question 21, in case you don't know the formula for percent of increase or decrease, it's the difference of the two numbers over the original number times 100. And that gives it to you every time. All right, come on. Okay, lay the marker down. There we go. Okay, so in our next one, this is what you were asking me about earlier. This is a right triangle problem, and obviously a trig right triangle problem. So first thing you should do is take your picture over here and label. Across from 75 is opposite, and next to 75, the other leg is adjacent, because we know this longest side is the hypotenuse. Now, the two that are labeled are opposite adjacent. So if I just write the mnemonic by saying the words, some old hippie caught another hippie tripping on acid, then I realize this is my problem, because I have opposite and I have adjacent. So I have tangent of 75 equals 170 over x. And then we think about the 3 different ways to solve a trig problem. If x is missing on top, you cross multiply. If x is missing on bottom, you switch the diagonal. And if x is missing in the trig, you inverse it. So of those 3, what do I need to do? That's right, I need to switch it. And when I switch my diagonal, it makes this answer. So that's the 3 ways to solve. If x is on top, you cross multiply. If x is on bottom, you switch the diagonal. And if x is in the angles position, you inverse trig. And by that, you can pick up your answer quickly. That is, if you know the mnemonic. Okay? Is that good for everybody? All right. Oh, I keep forgetting. I've got it laying over top of it, so I got two things that I'm having to do. All right. I need to probably minimize that thing up there, but oh well. 24. Graph of the equation that passes through these points. And you have all these choices. All right, first of all, which point in this list is most important? That's right. Why? Because that's your y-intercept. And that helps you rule out this one because that's positive 4. You with me so far? All right. Now, you have two choices. You could graph it and count rise over run to see which one it is. Because if it was negative, it's going to be pretty obvious, right? Another thing you could do is you could do y2 minus y1 over x2 minus x1. And I always try to pick 2 points that has the least amount of negatives, so I'd use the last two. Because you could do negative 1 minus negative 4 over 2 minus 0. That's going to change to plus or positive, make 3 over 2. Graphing's the other way, and it's not much different because you could graph the negative 4 y-intercept, and you could graph the 2 negative 2 positive 2 negative 1 and count up 1 2 3 over 1 2. You can see it has positive slope, so graphing would work as well. So just as a matter of, do you want to calculate it or do you want to visualize it? And everybody's a little different on that. Okay. Oh, I keep forgetting. Let me close this one out. No, that's one of the things we don't get. It's so you have to just make the best graph you can. All right, y'all asked for 25. System equations to find the value of y. So that means I don't care what x is, right? So in a system with two standard form equations, if you want y, make x drop. So what would I have to do so these x's would be alike? All right, and I'm going to multiply by negative 3, so they'll also be the opposite. Does that make sense? So they'll drop. So negative 3x plus 6y equals negative 30. And 3x plus 5y equals negative 3. And these drop out, giving you 11y equals negative 33, and then it's obvious it divides to make negative 3. Is there an easier way? Yeah, that is the easiest way. Yeah. The only other thing you could do is graph it, and without graph paper, that wouldn't work very well. Oh, yeah. Yeah, that's the other way that a lot of students do. A lot of students try to make the y's drop out. All right, let's talk about this problem because some of you had questions about this one. You've got scientific notation over here, and I know it doesn't really look like it, but anything times 10 is scientific notation. It says residue to the nth power, so that means I put the nth power on the whole thing. Doesn't that give everybody the nth power? So if I give p the nth power, well, it won't be that one, and it won't be that one. And what do you do with two powers when there's a parentheses between them? There you go. Okay. Well, I'm recording it just in case somebody don't get here, but I'm hoping that I get this done in a few minutes and we can talk about AP. I was just trying to do this college placements test stuff first in case everybody's running a little late, and they could watch the video themselves. Yes, because everything's raised to the nth power. So that means you got to give everybody that power. Everybody good with that? Okay. So on number 27 it says, what's the larger of the two real solutions? Well, I guess you have to get them both and pick which one's bigger, right? So to solve this problem, all quadratics must be equal to 0. Can you give me two numbers that multiply to be 36 and add up negative 36? Well, I guess we ought to make a list because that's kind of a big list. 136, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And which one has to be positive is the one that's the biggest. So the negative has to be here to make it negative 36. 3 and 12? All right, now those are not the answers to the questions. That's the answers to the parentheses factorization, right? So you got to plug those in and make them the opposite and then choose which one's bigger. because the solutions are what it is when you pull it out of the parentheses. A lot of times students don't do that, and they end up with the wrong sign.
I guess checked on
It works. All right, y'all didn't ask for 28, so we're going to move on. Okay. Let's talk about number 29 since we were talking about linear a few minutes ago. All of these are in what we call general form because they're all equal to 0. It wouldn't be very hard to turn them back to standard form because you could just move the constant over. Not that that would be extremely helpful in this process, but that's something you could do. What I would suggest doing is start with point slope. That same formula we use to get tangent lines in calculus problems. If you make this plus 5 and minus 7 and work the question out, then you'll have negative 4/7 x plus 4. And if you take 5 away, you'll have y equals negative 4/7 minus 1. And if you multiply the whole problem by 7, and move this to the other side, and move this to the other side, then it's C. So the big thing is get it to y equals mx plus b, multiply by the denominator to get rid of the fractions is the best thing to do. No, I didn't flip. I used the rule about fractions. You can multiply the denominator times each one and it drops it on the one that has it, but it gives it to the others. So I did the whole problem by 7. And that's why these two got the 7 on it and this one dropped it. And then I just moved everything to one side. That's one way.
So it would be negative 4.
No, because it was negative and I moved it to the other side.
Negative 4 is not.
No, it's not. But you could have changed all the signs and add if it did turn out negative. The only other way to do this one, and this probably was the better way, but I don't know how much y'all know about this. The formula, this is A and this is B, and the slope formula is negative 1 times A over B. You could have checked how many of them had that negative 1 times A over B slope. And then, and if you had got your y equals mx plus b equation, you could have checked how many of them had that y-intercept by doing C over B. But that's why you would have had to make like this equal to 7 and equal to negative 63, because 7 divided by 7 is 1. But if I move this over and make this negative 7 divided by 7 is negative 1 and matches that. So there's a lot of ways you could go about it, but this one is like the straightforward one. Just plug it in point slope, turn it to slope intercept, turn it to standard, turn it to general. Now, you said you had some trouble with this one. What's a triangle make? 180. So all you had to do is add these up and set it equal to 180 and solve. Okay? But what it solves for is x, not the smallest angle. So that would be 10 and 2 makes 12x, and these two would make minus 24 equals 180. And if I add 24 to the other side, that would be 204. If I divide 12 into 204, I don't know if that goes evenly. I might have made a math error.
I got 25. I bet. What's that?
9 and 15 is 24, right? And 180 plus 24 is 204, isn't it?
17. It goes to negative.
Oh, it does. Thank you. So if that's 17, the question says which one's the smallest angle. So that means you got to go back and plug 17 into each one of these to figure out which angle it is. So like 3 times 17 is 51. 2 times 17 is 34. And minus 9 would be smaller than 51. Right? 34 minus 9. That'd be 25. I'm thinking that's the answer because I think 7 times that minus 15 is not going to be smaller. But a lot of times students stop when they get to 17 and that answer's there because they think they found the answer, but the answer's not x. The answer's the smallest angle. All right. You okay with that now? Okay. So then we talked about that one yesterday, so all we got left is this, and then we're going to look at part B of multiple choice. All right, the study of the relation of height to ideal weight in adult men is produced by this formula. Predict in inches the man's height if this is how much he weighs. So you plug in this for W, right? What would you do first? That's right. You would add this to it. Now that's going to make another whole pound, is it not? So I'm going to carry that over. That'll be 0, carry 1, 3, carry 1, 330. And unfortunately, that answer's there. So some students might stop and say, oh, I'm done. But no, we got to divide that by 5, which goes 6 times. That'll be 30. And goes 6 times. And that's the answer.
Oh. I accidentally just marked that one wrong.
Okay. So the key here is, with these questions, sometimes it's algebra based, sometimes you can think arithmetic also, because we just did that kind of solving it backwards, but we did it more like arithmetic because we didn't actually show our steps as solving equations. Okay, so the college placement test, that gets us through the whole thing. So next thing I want to do is I want to talk about B, multiple choice. I went through these B multiple choice questions and tried to think about ways I can talk about these that relate to things we've studied in the past, but also might have been twisted a little bit because of the AP questions sometimes twist things. This one, at first, when I first looked at it, I thought, what do they want me to talk about? Then I got to thinking, what does F prime stand for? Okay, and what do derivatives calculate? Slope. So we're going to compare slopes off this picture. Now this picture is the original function, okay? It is not a derivative graph, it's the original graph. So let's talk about the slope right here. If you had to give that a tangent line and talk about the slope there, what's the best description of that spot's tangent line can you talk about? Positive, okay. What about this one? 0. It's a little bit flatter. And what about this one? Negative. Now, of those 3 holes, which one has the smallest slope? Negative. 3. Well, 2 of them have that. 2 of them start off with 3s, the derivatives, the smallest one. Then what comes next? 0. Because 0 is 0. So it had to be D. Because negative numbers are smaller, 0 comes after negatives, and positives come after 0, right? So that meant 3 had the smallest slope, 0 had the next slope, and negative 3 had the biggest slope. Because this says f prime of 3, which means slope at 3, slope at 0, slope of negative 2. Does that make sense? I made a video so far, so you'll be able to watch it. And we've only done one question off of AP. We started with college placement tests in case people were running late. So if you want to pull out your B packet, you'll be right with us because we've only done one question so far. All right. Okay, number 77. Let H be the antiderivative of this formula. What does an antiderivative stand for? What's the opposite of taking a derivative? Integration. So H is going to be the integration of this problem. Everybody with me so far? Now, they give us a value of H of 5 is pi, and let's find H of 2. And this is on the calculator active portion of the test. Does everybody agree? So in this problem, the first thing you'd want to do is integrate the problem. Let the calculator integrate it for you and give you a formula. Not with numbers in it, but just to give it to you. And that way, when you integrate it, you'll be able to put a plus C on it. Then this is X and Y, and that x and y can be plugged in and you can calculate your c, then you can go back and plug 2 in and find out what it is. Now, I'm not going to go over the answer to that one right now. But I just wanted to talk about how to do that. Maybe y'all could try that this afternoon, and we can go over the answer. But does that make sense to y'all? If an antiderivative means integrate, would it make sense I'm going to integrate this, put a plus c on the end of the formula, plug this x and y in and find my c, and then plug in 2 to find the final answer to the question? Because you got to have c to be able to find 2, right? Does that make sense to y'all? We've done some problems like that, but we haven't done any quite this complicated. That would not be integral. Be able to integrate that by hand. That's why you got it's on the calculator portion. And we'll come back. We'll talk about that some more in a minute. Because if we have time, we might do it this morning. But I want to go through as many as I can talking about the notations and stuff. All right. Continuous function of f is positive and has a domain of x is greater than 0, meaning that it's all on the right side of the y-axis, right? Since the asymptotes are 0 and y equals 2. One's vertical, one's horizontal. So let's start off with that thought. I have a vertical asymptote here, and all my graph's going to be on that side of it. I have a y horizontal asymptote here. Now, it says the continuous function of f is positive. And it says it has a domain of x is greater than 0. Now, for the continuous function to be positive, what does that mean? Means all the values are positive, right? Okay, so I have to be on this side of that line because of the domain. Everybody understand that? Which of these two sections would have all positive values? The one at the top. Couldn't draw it any other way. It has two asymptotes. Asymptotes always have that kind of curve in them. Couldn't draw it like any other shape because it has to connect kind of down towards that corner where they all intersect. So now let's look at each one of these and see which one of these makes sense. All right, it's first talking about on the right of 0. What is the right of 0 doing? It's going up to positive infinity. Well, that rules out that one. Now, what's the end of the graph going to? It's going to 2 because it's flattening out to that line. Everybody agree? So that's why the answer is this. So knowing something about horizontal and vertical asymptotes can help you out tremendously in this problem. Now, if they'd have told me my function might could have been negative, I'd have drawn it down here, and it had been upside down. If they'd have told me my domain was over here, that just changed my shape. Because look, it can be in any of these corners, right? I just had to know which corner it was in to know which shape it was. Does that make sense? All right. All right, on number 79, it says the file is downloaded in a computer at a rate modeled by the differentiable formula f of t, where t is the time in seconds since the start of the download, and f of t is the measure of megabits per second. Which of the following is the best interpretation of f prime of 5 equals 2.8? Well, first of all, let's talk about the original function. The original function, t stands for seconds, and the function itself, the y value, is megabits per second. It's already a rate. Everybody agree? So if you have a rate, and you take the derivative of a rate, what does it become? Kind of like acceleration. Yes. Yes. It's already per second, so if you take the derivative, it's going to put another per second on there. Does that make sense? All right, so when we read through the questions, the first thing I noticed was that kind of thought. Only one of them said that. This one just says per second. This one says per second per second. This one just talks about the seconds and says bits. This one talks about the average being per second. But the key is, if you take the derivative of that, it's going to have to be per second, because the derivative of a rate is acceleration. Even if we're not talking about driving down the road, it's still acceleration. Rate is exactly right. What rate is it going? And that's why it's increasing that.
It's just the first equation.
Now, if the first one had just been megabits right here with no per second on it, then it would be A. It's B because it says mega per second per second.
Okay. So that one's just marked.
Oh, did I mark it wrong? I'm so sorry. I am real bad for that. Sometimes I'll see the wrong answer for so long that then when I see the right one, I'll mark it wrong. That's why I wanted y'all to go through these, because I could have made a mistake too. The first derivative is given by this formula. On what interval of the graph is concave up? Okay, first of all, what does the first derivative give you? If you set equal to 0. Maxes and mins. Now, this is on the calculator active portion of the test. So you could solve that on your calculator by doing solver, right? You could set this equal to 0 using the solver button and say x is equal to what? Now, I'm going to just tell you what it is to save a little time. It was 1 and 3. Now, what's the second derivative tell you? Tells you concavity. So we take this and find the derivative and set it equal to 0. And that way we'll have all the numbers we need in our table to look at concavity, because you would want to make a table for this problem. And that came out to be x equals 2. So if I solve each one of them, the first derivative and the second derivative, and find my numbers, then negative infinity, I'm sorry, y'all, there was 2 numbers for this. Hey, Mike.
Still dealing with the staples.
Yes, we're out of staples, and I haven't gotten any, but if you could go to the office and get some, I'll put it in, because it's missing. So we have to do negative infinity to negative 1, negative 1 to 1, 1 to 2, 2 to 3, and 3 to infinity to see what our concavities are in this, like we did on the 10-step problems back in last class. Remember that? Making a chart. Then you'll pick your numbers and plug them in and see what it does. And it'll clearly show you something over here. Now, sometimes you can just do the math kind of in your head if you pick certain numbers. For example, in between negative 1 and 1 is 0. And if I plug 0 in this, isn't it going to come out negative? Okay. If I pick negative 2, negative 2 cubed is going to be negative. Everybody agree? That's going to be negative 32. Okay. Then negative 2 times this is going to be positive 24. And these two are bigger than that one. Would you agree? So it's negative. See what I mean? You don't have to work it all the way out. You just kind of figure out what sign it is. This is also calculator active. Exactly. So you can use your calculator, yes. But for right now, I'm just trying to go a little quicker. So far we found out these two are negative. All right, let's rule out how many answers those two are. Okay, which ones up here can I not use because these intervals are negative? Okay, definitely D, because negative infinity to 1 was this first one. We've got negative 1 to 2, which includes this one. So we're good so far, right? Well, this one too, because 0's in that one. Oh, well. All I did was check out a bunch of negatives, and I got the answer without having to try all of them. Because 0 to infinity is in this part over here, from 0 to 1, and that's already negative. Yeah. If I got these two are negative, and I didn't even get the rest of them, I just wanted to see how many answers could I rule out, because the first two, when I plug in negative 2 and I plug in 0, I got negative numbers, which means they're concave down. I'm looking for concave up. Okay, so I thought, well, these two have a lot of 1s and negative 1s and stuff up here, but let's rule out a bunch of answers. Maybe it'll rule a bunch out. Negative infinity to negative 1 is not concave up because it's negative. Concave up is positive. This one's negative. That one's negative. I can't use it. From negative 1 to 2. Well, if negative 1 to 1 is negative, then negative 1 to 2 can't all be positive, can it? If 0 is in this one and it's negative, then it can't all be positive. So I ruled out all the answers but the one it really is. And if I had finished out the whole entire chart, I would have seen that a lot more of these were positive. But by just picking out these two, which was in almost every answer, I was able to rule out a lot without finishing the chart. Sometimes if you'll look at the answers and see what numbers are in there a lot and just do that part of the chart, you can get there a little quicker and save some time. All right. Let's look at number 81. I thought this was whoop, I went too far. I thought this was a really good problem because it relates to something we were talking about yesterday. This is actually a derivative graph, okay? Because they're telling me to take the antiderivative of f. And an antiderivative means integrate it, right? And if I integrate it, it goes back to the original problem. Everybody agree with that? So this is the derivative graph, and these are the graphs that it makes. So let's talk about each very important place on my derivative graph. So yesterday we talked about if it's below, that means decreasing, right? And above means increasing. What happened here at this point between negative 2 and negative 1? Is that a max or a min? It decreased, and then it increased. That's a min, isn't it? All right. Is this a min? No. Is this a min? No. Is this a min? Is that a min? Okay, so we ruled out two answers already. So now we've got to go look at another spot to see, you know, what's going on in some of the other places. So, whoop, wrong way. You could do that. You could also see that it only crosses the x-axis twice, so it can only have one max and one min, or two maxes or two mins. And if you look at this graph right here, doesn't it have more than that on C? So it has to be D. So you can judge it on the increase and decrease. It decreased a little while, then it increased for a long time, then it decreased for a little while. Is that what D looks like? You could have just done it on increasing and decreasing more than likely, but knowing how many maxes and mins there are, that there's one min and one max, also gives that away. All right. So writing on your picture can be very, very helpful. I wish this would go a little faster, but I have to keep clicking it.
See what they say. It's like, it's just the graph of F. I don't know if it's...
Right. I would pay more attention to what it said about the graph instead of the notation F. It said these at the bottom are antiderivatives, which means you integrated it, which means that was a derivative graph originally, whether they put the mark on it or not. All right. This is calculator active. But this problem, it took me just a little while to figure out how they got to answer this because I had to think about one little small thing. Is it all above the x-axis, below the x-axis, or a little bit of both? So I graphed it. And what I found was it was a little bit of both. And that's a problem. Because when somebody asks you to find total distance, everything on the bottom always comes out negative. And you got to take that negative sign off and add the two of them together. So what I did was first, I decided, well, because that graph was kind of like that it looks something like this. I'll try to go draw you out a little piece here. It looked like that from 0 to 2. So I needed to know where this place was because I need to do two integration problems. So I took the velocity formula and set it equal to 0 because that would tell me when it crossed the x-axis. And once I got that number off the calculator, then I was able to say I want to integrate from 0 to that number, this formula. And I wrote the answer down. And then I integrated it from that number to 2. And I wrote that answer down. And then if it came out negative, I threw the negative away and added them together. Because this one will come out negative because it's below the x-axis. but I don't want it to be negative. So I couldn't do it from 0 to 3, because that's what I tried first. And I figured that's probably what y'all tried with your calculator. That does not work, because it takes this one away incorrectly. And you wanted to add it. So that's why you've got to do them in pieces. And I worked it out. This came out to be about 1.57 when I did the equal to 7. So if you do this one, and then you do this one, and you take the negative off of it and add them together, it comes out to be the answer for D. So if y'all want to try that and make sure you understand that, then that's, something you could practice. With question number 83 down here, it says this is a derivative formula. Which values of x does it obtain a relative maximum? Well, how could I figure out where there's a maximum? I could set it equal to 0 and solve it to find out where those are. I could also graph it first, because maybe if I graph it, I could figure it out from the graph. So that's what I tried, because I thought, well, we just did a graph earlier. Looking at the graph, we knew where the maxes and mins were. So I graphed this question, and I didn't write the whole thing on my paper, but I think it did something like this. And that was the number 1, and I didn't write a bunch of numbers on my graph, but it was something like that. So it crossed 3 times. This is a derivative graph, right? So if it goes from decreasing to increasing, isn't that a min? If it goes from increasing to decreasing, isn't that a max? And then this one over here is from decreasing to increasing, so it's a min again. So this one was my max, and it was between 0 and 1. How many answers are between 0 and 1? 1. Do you see why graphs are really important? It gives it away immediately, and you bank a lot of seconds for another question. So that's something on multiple choice that can speed it up a little bit. All right, in question number 84, this relates to some word problems that we actually have practiced a lot of when we were doing that packet one day. Come on. So if your number of bacteria is increasing at a rate of R of T bacteria per hour, and there's 1,000 at times 0, how much will there be at 3? Well, we know we started with 1,000, right? So these two started with 1,000. These didn't do anything about it. Second of all, this is a rate. And if you take a rate, what do you want to do to it? Derivative or integration to get it back to the original how many bacteria? Integrate. Because that's a rate. You want to integrate it back to like not per something. And that's why it was D. I had looked very carefully at number 85, thinking about the answers. To me, this question was just a little tricky because it seems like all of them would be kind of feasible. If you have a function, g, that's on a closed interval from 1 to 4, not even looking at the numbers they gave me, which of the following conditions could you guarantee that there would be a number c in the open interval for g prime of c is equal to 1? First of all, if it's continuous on the open interval, what does it have to be on the, closed interval, what does it have to be on the open interval? It's continuous on the closed, it is differentiable on the open. So that's a possible answer. Would everybody agree? That's based on Rowley's theorem and mean value theorem that says that it has to be a closed interval continuous and it has to be differentiable on that closed interval. Now, we don't know if it's increasing or not, but it looks like from this point to this point it did increase, but who knows, it might have decreased somewhere in between there too. A maximum value. Well, I don't know if there's a maximum value between there, because I don't know if it increased and decreased or if it just increased the whole time. The graph has at least one horizontal tangent, and during that, I don't know that. The only thing I know is it's differentiable on the open interval. Exactly. That guarantees you, because it's continuous on the closed, it has to be differentiable on the open. Right, exactly. Oh, well, good for you.
I think I thought that one through, but not so much. So,
Yeah.
All right, number 80C says twice differentiable. And that to me is a little tricky. If it's twice differentiable on F, G, and H having a second derivative given above, which I went too far, which of the following has a graph that has exactly 2 points of inflection? And this is the graphing portion of the test, right? These are second derivatives. Could you just graph each one and see which one only crossed the x-axis twice? Would that be a good idea? Yeah. Yeah. When it says 2 inflection points, the second derivative equal to 0 means that it's going to cross like twice. I don't know what the graph of this one looks like, but it's going to do that. Okay? With it having these things like this right here in there, with the 2's and the 3's on it, that usually means multiple answers in multiplicity. I don't know if y'all remember that from Math 3. So that might mean that the graph actually has something that comes down and like sits on it like that, for example. That would be a multiplicity. So who knows what it might do. But you're looking for the one that only touches twice. And those are already the second derivative. Now, the correct answer to that question was C. I kind of thought that was interesting that F works because there's no adding and subtracting on it to shift it a little bit. You would think if you shift it up a little bit or down a little bit, that would cause it the 3 different numbers that make this 0 to shift one of them off. But it must have something to do with these 2 numbers being so what they are that it didn't. All right, we'll pick up on number 87 in class. And I'll post this because we did the college placement test this morning before some of y'all got here. So I'll post the video so if any of you want to watch the college placement test questions, you'll be able to.